Welcome to OPIC. In this lecture of Theory of Computation, we will be defining alphabet, strings and languages. So let us start with alphabet. Alphabet is defined as a finite non-empty set of symbols. So what does this mean? It means that if we take some symbols like alpha, beta, okay, we have taken two symbols and we make a set of these two symbols, then this whole set will be called an alphabet. Alphabets are usually defined by this symbol sigma in the books. Okay, suppose that we take symbols 0 and 1 and the set of these two symbols will be called alphabet. Okay, so how many elements must be there in an alphabet? So it says it should be non-empty. The set should be non-empty. So we cannot have a set like this. If we say this, so this will be an invalid alphabet. Why invalid alphabet? Why? Because the set of alphabet must contain at least one element. So number of element in an alphabet must be greater than 0. Now let us move on to strings. So a string is a finite sequence of symbols over an alphabet. Finite sequence of symbols over an alphabet. Suppose that we take an alphabet like this, 0, 1, okay, and we write these two symbols in a sequence, like I write 0, 1, or I write 1, 0, or I write 0, 0, 0. Okay, so these sequences of symbols present in an alphabet are called a string. So this is a one string, this is another string, and this is another string. Okay, now let us define the length of a string. What is the length of a string? Length of a string is actually the number of symbols used in that string. Suppose that I write a string like this, 0, 0, 0, 1, 1, 1. So the length of this string will be 6. Okay, I am defining the strings on this alphabet. The alphabet consisting of two symbols, 0 and 1. So this is a string with 6 symbols. So its length will be 6. Okay, so in a string, the length can be 0, 1, 2 or anything. Like suppose that I am writing 0, 0. So this string has length 2. I am writing 0, 1. This string also has length 2. So the length of a string can be greater than or equal to 0. Okay, let us understand this thing. Suppose that we are given this alphabet and we have to write all strings present in this alphabet. So how will we do that? So first of all, we will write the string with length 0, length equals to 0. Okay, so this string with length equals to 0 is denoted by symbol epsilon. Okay, then we will write strings with length 1. So there will be two such strings. One is 0 and another will be 1. If you write strings with length 2, then we will have 4 strings, 0, 0, 0, 1, 1, 0 and 1, 1. And if we write strings with length 3, then we will have 8 such strings, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1 and 1, 1, 1. Okay, so similarly we can go on and on and on and on. Okay, there is no limit, okay, of the strings that can be written over this alphabet. Hope this clears your concept of a string and the length of a string. Now let us move on to language. So language is defined as any set of strings over a given alphabet. Okay, suppose that there is an alphabet 0, 1 and we form some strings over this alphabet, and we take any set of such strings. In that set will form a language. Suppose that we are writing some strings 0, 1, 1, 1. Okay, I have written 3 strings. If we take the set of these 3 strings, then this will form a language. Suppose that I name it language 1. Okay, if I take another set of the strings made over this alphabet, then that will form another language. Suppose that I am taking 1, 1, 1. Okay, these 2 strings written over this alphabet. The set of these 2 strings will form another language, language 2. Okay, so a language is nothing but any set of strings over an alphabet. Suppose that I am taking alphabet as alpha and beta. Okay, and the strings that I have formed over these 2 symbols is epsilon, that is 0 length string, alpha and alpha beta. So the set of these 3 strings form a language. Suppose that I name it language 1. Okay, so this set is a language which has 3 strings. This string is of length 0, this string is of length 1, this string is of length 2. Okay, suppose that I give you a language like this 1, 0. Okay, so what can you tell me about this language? You can tell me that this is a language in which there is only one string, that is 1, 0, and the alphabet seems 0, 1. So alphabet is 0, 1, and this language has only one string, that is 1, 0. Okay, if I give you this, what you will tell me? You will tell me that this is a valid language with only one string and length of that string is 0. Okay, so we can categorize a language into 2 parts. One is finite language and another one infinite language. So what is finite language? Finite language is nothing but just a language in which the number of strings is finite. Number of strings is finite. Similarly, infinite language is the one in which number of strings is infinite. Let us see the examples of both of these. Suppose that I define 3 languages over alphabet 0, 1. Language 1 is epsilon, language 2 is epsilon, 1, 0, 0, 1, and language 3 is epsilon, 0, 1, 1, 1, 0, 0, 0, 1, 1, 0, and so on. Okay, so what can you tell me about nature of these 3 languages? So language 1 is finite. Why? Because number of strings is 1, only one string. And language 2 is also finite because number of strings present in language 2 is 4. But language 3 is infinite language. What does this mean? This clearly means that number of strings in this language is infinite. Okay, another term often used in the books is complete language. So let us try to understand what is a complete language. So complete language is nothing but just a set of all strings which can be made over an alphabet. So what does this mean? Suppose that I take an alphabet sigma equals to alpha. Okay, so this is an alphabet with only one symbol. Okay, how many strings I can make over this symbol alpha? So I can make one string with length 0, that is epsilon. I can make another string with length 1, that is alpha. I can make another string with length 2, that is alpha alpha. I can make another string with length 3, that is alpha alpha alpha, and so on. Okay, if I take a set of all these strings, then I will get what is called a complete language. Okay, so this language will be a complete language. Complete language is also denoted by sigma star. Okay, So we can write this L as the sigma star. Suppose that we are given alphabet equals to 0, 1, and we have to write sigma star all the languages. So how we will write it? We will write string number first, that is of length 0, then strings of length 1, 0 and 1, then strings of length 2, 0, 0, 1, 1, 0, 1 and 1, 0, then strings of length 3, then strings of length 4 and so on. So this whole set will form the complete language. Okay. Now let us move on to discuss what is substring. Substring is defined as consecutive sequence of symbols over a given string. So consecutive sequence of symbols in a string. Suppose that for an example, I take a string 0, 1, 1, 1, 0, 0, 0. Okay. So in this string, if I take a sequence of consecutive symbols, suppose that I take this sequence. Okay. So this sequence will be called a substring. Okay. If I take another sequence, like suppose that I take this sequence, that is 1, 0, 0, this will also be a substring. So the sequence should be consecutive. Okay. So now let us see how many substrings in total we can get from a string. Suppose that I have a string of length 3, that is A, B and C. Okay. So how many substrings I can form from this string? So first of all, I will make substrings of length 0. Okay. That substring will be, as you all know, epsilon. Okay. Then I will make substrings of length 1, like that will be A, then B and C. There will be 3 such substrings. Okay, then I will make substrings of length 2, that will be AB, the next will be BC and next will only 2. Okay, I can make substrings of length 2, only 2. Then substring of length 3, I can make ABC, only 1 substring. So how many substrings are there? 4. Okay, now let us take a string of length 4, A, B, C, D. Now how many substrings I can form? First of all, substring of length 0, that is epsilon. Then substring of length 1, we can write A, B, C and D. Then substring of length 2, we can write AB, BC, CD. Then substrings of length 4, 3, that will be ABC, ABC, BCD. Then substring of length 4, only one possible, that is ABCD. Okay. So how many total substrings? 1 plus 4, that is 5, 6, 7, 8, 9, 10, 11. Okay. If we have been given a string of length 4, then we can make 11 substrings. If we are given a string of length 3, we can make 4 substrings. So now the question arises, if we are given a string of length n, a string of length n, then how many substrings we can make? Okay, now let us try to see this. Suppose that we have a string of length n, alpha 1, alpha 2, alpha 3 up till alpha n. Okay, this is one string. So in this string, we can make substring of length 0. How many substring of length 0? We can make only one, that is alpha. How many substrings we can make of length 1? Clearly we can make n such substrings. For example, we can make alpha 1, alpha 2, alpha 3 up till alpha n. Okay. How many substrings we can make from this string which are of length 2? It is very clear that that number will be n minus 1. How I can say this? Because the first string will be this, second will be this, and the last one will be alpha n minus 1 to alpha. So this is first, this is second, and this is alpha n minus 1. It is n minus 1th. So how many strings of length 2 I can make? It is n minus 1. How many substrings of length 3 I can make? This is n minus 2. And moving so on, how many strings of length n I can make? That is n minus, this was 3, so it was 2. It was 2, so here we have 1. So of length n we can make n minus 1, that is only one string. Okay. If we sum all this is 1, this is n, this is n minus 1, this is n minus 2, and in the end we have 1. If we sum all this, that is 1 plus 2 plus 3 up to n minus 2 plus n minus 1, so on, plus n minus 1, and then in the end plus n plus 1. This one is for this epsilon. So we all know that 1 plus up till n, this is n plus 1 upon 2, and then plus 1. This one is for the substring of length 0. So if we are given a string of length n, then we can make n plus 1 upon 2 plus 1 number of substrings. Now let us solve another question. So the question says, how many k length substrings are possible over the string of length n? So the question says, how many substrings of length k can be made from a string of length n? So we are given a string of length n, that is alpha 1, alpha 2 up till alpha n minus 4, alpha n minus 3, alpha n minus 2, alpha n minus 1, and alpha n. So this is a sample string of length n, and we have to make a substring of length k. Okay. Now let us solve this problem by taking different values of k. Suppose that k is 1, so we have to make a substring. We have to make substrings of length 1. So how we will make one substrings of length 1? We will take alpha 1, then we will take alpha 2, and so on. We will take alpha n minus 2, then alpha n minus 1, and alpha n. So if k equals to 1, we will be able to make n substrings. Okay. Now let us take k equals to 2. Okay. If k equals to 2, the first substring that we will make will be alpha 1, alpha 2. Then the second one will be alpha 2, alpha 3. And we will continue the process, and the last one will be alpha n minus 1 to alpha n. So total substrings thus will be n minus 1. Okay. If k equals to 3, then what we will do? The first substring that we will make will be alpha 1, alpha 2, and alpha 3. Second one will be alpha 2, alpha 3, and alpha 4. Moving so on, the last one will be alpha n minus 2, alpha n minus 1, and alpha n. So the last one will start from here. So total substrings we will have n minus 2. Okay. If we continue changing the value of k up till k equals to k, total number of substrings that we will have will be n minus k minus 1. As you can see the pattern in the above 3 cases, when we had 1, this was n minus 0. When we had 2, it had 2 minus 1, that is 1. When k was equals to 3, then here we had 2. That is, what you can understand is the number we have over here is 1 less than this number. Okay. So when we have k here, so number here will be k minus 1. Okay. So n minus bracket k minus 1 bracket close. So this will be equals to n minus k plus 1.